Welcome to The Power of Code, how we transform students into developers, not just users, which will be presented by Ms. Lisa Finch from Dubai English Speaking School.
Thank you very much for that generous introduction. I'm Lisa Finch. I actually work at Dubai English Speaking College, which is slightly different from the school. The school is the primary and the college is for the older children. Before we begin, I just want to explain to you the personal journey that I've been on in the last 18 months in terms of allowing my students to not just code, but to become developers as well as users. And I think that's a key thing for your students, to be able to create products and be inventive, be innovative, rather than just sitting there in front of a computer or sitting holding a tablet and using someone else's tools or products. About 18 months ago, there was a big hoo-ha in the press, especially in the UK, how students, young people, were not doing enough coding. They weren't looking to the future. In 5 years' time, there's going to be a huge deficit in the number of students who are going into industry with the correct skills that allow them to become developers. Whether it's a software developer, whether it's games production, whether it's something a little less sort of exciting, as you like, something like database, analysing data, that sort of thing, even data security. And in line with what was going on in the UK and these big announcements in the press, we decided at DESC that we had to change the way we delivered our computing curriculum. In fact, it wasn't called computing then, it was called ICT. Okay, students came in, they sat in front of a row of computers, they turned it on, they used Office products. If they were really lucky, they might get a unit on maybe Dreamweaver or Fireworks or Photoshop where they could be a little bit more creative. But that was about it. You know, they were going home, and it was at home where they were feeding their imaginations. They were getting on the internet, they were finding free software, they were looking at interesting websites, they were discovering apps and how to develop at home. And we thought, right, we've got to tap in on this. We've got to learn how to harness this enthusiasm that they clearly have for this, and also to think to the future. So we started wondering, well, what jobs are these young people going to be applying for in 5-10 years' time? And the simple answer to that question is, we don't really know. We can look a few years in the future, but that's about it. If you cast your mind back 5 years, who'd heard of wearable technology? Google Glass. All these new things are coming out, they're being created, they're on the market, and it's taking a really short amount of time for these things to come into being and for our students to start using them. But more importantly, for those things to be the inspiration, the starting point for our students. So we wanted to think about what they're going to be doing in the future and how it linked to our curriculum. Sorry, this mouse is a bit cranky. This young man, and we show our students this video, 12 years old, I think it's a few years old now, but he presented at one of these TED Talks. And I'm just going to play this short video just to give you a flavour of what someone so young can achieve and aspire to be like. Hope the sound's on. I knew that was going to happen. When you ask someone if the sound is working and they tell you yes, there's an element of trust, isn't there? Never mind, hopefully, could you ask the... Yes, if he can come. We'll maybe have a look at that at the end of the presentation. Okay, my talk today is labelled coding, but it's not really just about coding. It's about where coding can lead you and your students to. Yes, it's really important that they can do some programming, that they can maybe make some games in Scratch, or Tinker or one of the other programs online, or something that you might have in-house. However, that's just the starting point, because it's the whole learning process that goes with that, with learning to program, with learning to code, that I think is really important, and which gives your students transferable skills which they can use in other aspects of learning at school and at home. When someone learns to code, it's like learning another language. It's not a language that you speak, it's a language that you write down, and invariably you make mistakes. The problem with coding on a computer is, if you get your code wrong or your syntax wrong, it's not going to work. All you get is a nasty error message appearing on the screen. And what we've trained our students to realise is that that error message is actually a good thing. When we get criticised or something doesn't work properly, sometimes it deflates us, it demotivates us. But what we've tried to do is instill this thinking that errors, failing is a really good thing, because by doing that, you've got the path to success. There's a feedback loop. You can improve, you can refine, and ultimately you'll get there in the end and you'll create something which was infinitely better than your starting point. So if at first you fail, don't give up. In fact, we encourage people to take risks. Right, now I need to go to the next slide. Now it's not changing. Okay. Okay, our main mantra is that we need to get our students to learn by doing. I'm interested in something called design thinking, which was created by Stanford University, and it's a model that they use in industry to help encourage entrepreneurship and innovation. It's used by design studios basically when they're creating a new process, a new service or a new product. And we've decided to adapt that and use that in school with our students. And it's not dissimilar to the processes that are linked to project-based learning. If any of you have seen Austin's Butterfly, the video, which is Ron Berger's, have any of you seen that, Austin's Butterfly? No? One thing I can highly suggest is watch the video. It's on YouTube, okay? And it shows a first grade student's work. He's been asked to create a butterfly. I wish I had it on my computer and then I can show you. And this butterfly, he's got a photograph, and it's a beautiful photograph, very sort of highly decorated real life butterfly. And he's this big. And he's been asked to recreate it on paper. So obviously he starts off and he's got this sort of like really childish rough sketch. But he's in one of these schools where they really promote this idea of evaluation, feedback and improvement. So they sit him in front of the class and he's got his work and the class give him feedback. And bear in mind, these are small children. And eventually, after about 6 steps of continual evaluation and feedback, the end product is something really quite amazing, and something that most adults probably wouldn't have been able to produce. And when you think that it's been made and achieved by a little boy who's in first grade in this American school. And that's another thing that we want our students to do, constantly evaluate, constantly improve, because that is the way to produce something really different. We encourage them to get their hands dirty, try different things. Don't be stifled by this idea that you have to do things in a certain way. I don't tell my students to use one particular type of software when solving a problem. Like you need to use PowerPoint, or you need to use Dreamweaver, or you need to use Python. I say to them, use what you think is best for solving this problem. And sometimes they say, well, Miss, I don't really know. There's a bit of software that I've seen online, but I'm not really sure how to use it. So what do you think I say to them? Go away and have a go. Don't be boxed in by the knowledge that you have. Think outside. Think about where it can lead to. If you put in a little bit of time and energy, go off and try it on your own, spend an hour or two at home, go to the library in school, get together with some friends, collaborate perhaps. Mr. Edison, he was really good at doing this. He had big teams of inventors working at his factory, trying to come up with new ideas. A lot of them he basically stole from other people as well and readapted them, which is what goes on today in industry and entrepreneurship as well. But then every now and again he would come up with something whiz-bang and amazing like the light bulb, and it would change the world. And that's what I say to my students, you know. You can be like Edison. You might create 50 different things. 49 of them might not be successful. They might not work properly. They might not meet the needs of the client. But that one thing might have the wow factor. So how do we go about this? Actually putting it into practice in the classroom. Project-based learning, PBL. Also problem-based learning. We give them a situation or a problem that's linked to real life. If we don't make it linked to real life, they haven't got any real grasp of it. It has to be something that they can relate to. We encourage them obviously to work in teams, but we also give them the choice to work on their own. Once again, asking them to work in a team is being very specific and it's constraining their creativity. We let them decide. One thing we do tell them to do though is share ideas. And that first idea that they come up with, perhaps as a team or perhaps on their own, may not be the idea that they then work with. Sometimes we get them to swap ideas. We get them each to create an idea, and we might have 25 ideas in a classroom, and we put them all on the floor and we decide which are the top 5. And then we give one of those ideas to each of the teams to work with. So their starting point will probably not be their end point. And then this idea of incremental design, the feedback, the evaluation, and the improvement. And that's how we set them free. And that's literally what it's about. If you want your students to be really, really creative and innovative, don't put them in a box. Yes, you still have to be in control of what's going on in the classroom. Yes, you have to keep track of where they're at. So we have weekly check-in sessions where we sit round in a big circle for the first 5 minutes of the class, and one by one they tell me and the rest of the class where they're up to with their project, or as a team they do that. Check in, blah blah blah, check out, then goes on to the next one. And it's a really good way of showing, yes, they're making progress, they are moving forward, but also that gives other teams and individuals that chance to feed from their ideas as well. So they act as inspiration for each other. Give them a theme. Now, our themes have been really we started off being quite specific. You know, create a new mode of transport that would use green technology. Typical sort of teacher stuff. But then we thought, right, okay, well that's sort of like still being very directed, isn't it? We're still sort of like really telling them what to do. So then we thought, right, we're going to open it up a little bit. So year 7s, this year, heroes. That's it, just one word. What are you going to do? What are you going to create? Are you going to create a video game, a program where you are the hero, where someone else can become the hero? Is it about heroes in society, something that could help some aspect of society, like healthcare? Is it a movie? Could be anything at all. An app, it could be anything at all. And that's what we want them to do. We want them to think more broadly about problems. The year 9s have got a bit of a struggle, because all we're doing is giving them a box, a paper box, a cube. A bit like a Rubik's Cube, but nothing moves. Just give them that. What are you going to do with that? Most adults would have to sit there for 10 or 15 minutes having a good think about it. What can I make out of a paper box, a cube? And then they start thinking about things. You know, they start thinking about an entertainment cube that can move around, holograms, all sorts of weird and wonderful things. So the process involved, how do we get there from start to finish? And this is design thinking stuff. As I say, this comes straight from Stanford University's design school. And industry. First thing you do, you have to work out who you're making your product for. Who's the target audience, the persona? And we get them to actually create a real persona. It's not a real persona, but it's a made-up persona. This idea of the end user. And they have to actually decide what their name is, where they live, what they do for a living, where they go to school if it's a younger person, what sort of person they are and what they need. And once you've got that out of the way, you know who you're designing for, and it makes it a lot easier. Secondly, ideation. It's one of these trendy words that they came up with at Stanford as well. It basically just means to create and come up with some ideas. Now, how you do that is up to you. I mean, as I say, I found this idea of sharing ideas and collaboration at the starting point to be really useful and effective. But there are so many different ways that you can do it. And if you go online and you have a look at design thinking, there's loads of stuff from industry where they do this all the time. Prototyping. Prototyping doesn't have to mean making something on a computer, even though I'm talking about coding. It can be making a walkthrough. Say you're designing something for an airport. The students could make a big walkthrough on the floor of the customer experience from start to finish and how their idea fits in with that and whether it will work. The idea of a prototype is to see if their product will actually have some legs in the real world. Is it doable? Is it makeable? If they're creating an idea for a new communication device, not necessarily a smartphone, we get them to make it out of paper, cardboard, Lego, anything at all. Even spaghetti and marshmallows has been known to be brought into the classroom, although that gets a bit messy sometimes and they end up eating half of it, even the spaghetti, which they're not supposed to. Evaluation. This is critical. When a design team decides to create a new product, they don't just walk into the studio, knock up an idea, a design, and that's it, hand it over to the production. It goes through a series of steps, refinements, before they get to the end product. They have to test it as well to make sure it's actually going to work. And that's what we get our students to do as well. If it's something they've made on a computer, it's easy to test. But even if it's a process, you know, if you're delivering business studies, think about processes from the real world and how you can transfer that into this creative, this way of getting the students to link the real world to what they do in the classroom and their creativity. And then finally, eventually, they'll get to the end product. They have something that may not quite be perfect, but it's certainly a lot better than what they started off with. If it's not, they just go back. And they maybe come up with a different prototype, get more evaluation and refine that. Now I'm coming at this from a computing perspective, okay? And some of you you might have heard of this. It's a bit of kit called Raspberry Pi. It's the new darling of the computer world. It's a new computer that costs about £30 UK money, so because I have to buy them from the UK at the moment. It's about 180 dirhams, I suppose. And it's like a mini computer. The students don't use it in school. We've got one set up at a desk, and they can use that anytime they want to. I don't say you can only use that during my lessons. They can come in lunch times, break times, after school and have a play around with it. But the beauty of this is they can buy them at home, and even if they don't have the tools at home, they've got the tools on this little mini computer that they can just attach to a TV or a monitor, add a mouse and a keyboard, and they can start creating things. You can do 3D design on there. You can create computer games. You can program. There's all sorts of weird and wonderful things that you can make with this. I met a guy called Alan O'Donoghue, who is from the UK. He came over here in November, and he's driving the popularity of Raspberry Pi across Europe. And I went to a dinner with him, and he turned up and he was carrying an empty Costa coffee cup. And I thought, what's he doing with that in here? We're at the yacht club or somewhere. And then I noticed there was a little red light flashing on the side. So I had a closer look. There was a Raspberry Pi in his pocket with wireless attached to it, and just dangling over the side of the coffee cup was a little camera. And he programmed it to take an image, a photograph of what was going on at this event every minute. And that was being relayed back to his computer in his hotel room. And he was recording what was happening. That gave him the power to be able to do that, this little device. And that can be the same for your students as well. I mean, we're looking into something called life blogging at the moment with wearable technology, whereby the students record everything that goes on in the school in a particular day, in a particular week, if we have any special events. And then we store that data, and in 5 years' time, students come into year 7, they can have a look back and see what life was like at DESC 5 years ago. Bananas. These bananas, bizarrely enough, control that computer game. Okay? And this is why we try and get our students to start thinking differently about things. Think about making your own games controllers. These are attached to a little circuit board called a makey-makey. I don't know why it's called makey-makey, but that's its name. Okay? Once you complete the circuit, you can turn anything that conducts electricity, like an orange or even human skin, into a conductor that allows you to control things on the computer, like games. We even had a piano keyboard, and we were playing music by tapping on the bananas because we were completing the circuit. So if they can do things like this, it shows them that they can perhaps go home and do other weird and wonderful things. And one day, one of those weird and wonderful things might turn out to be something that's really popular that they could sell, that could change the world. This is one of our year 8 students, and we gave them a task to take a bit of technology that we already have and change it. So he came up with a wireless mouse glove, so he can control his computer using this special glove. Now, these do exist in the real world. I've never actually seen one in the flesh, and I was a bit sceptical. You know, he's year 8, he's managed to cobble this together, and I thought, oh, this isn't going to work. But it did do. It was amazing. And we were all like, oh gosh, that's really actually very good, well done. But it just shows what you can do if you sort of push them in the right direction. We let them do prototyping on the computer. There are some really good tools out there now online that are free of charge. And then we get them to give each other feedback. This is something that the students made. Have you seen those interactive floor things where you walk across them and they all part? Okay. I went to London in January, and I went to the BET show. And they had one of these, and I said to the man, I said, how much is that? That'd be really cool in my school. I love these. I think they had one at Murdiff City Centre as well a few months ago. And he said, oh, I said, yeah, it's really good, but it's £12,000. How much is £12,000 in dirhams? It's a lot of money, isn't it? Yeah, we're talking a lot of money. I work in a non-profit school, okay? So I came back and I said to the students, we've got a team of digital leaders who 12, 13 students who help out around the school. They train staff, they give presentations. When we introduced Apple TV, it wasn't me that trained the staff up, it was the digital leaders, the students who did it. And I said to them, look, I've seen this great product, I want it, make it for me. And they all looked at me as if I'd gone bananas and sort of like, you know, we can't make that, miss. That's proper stuff. That's things they sell in the real world. 3 weeks later, we're playing football on our own interactive floor. They went away. They basically dissected the product, tore it apart into its component parts, and then thought, for each of those parts, how are we going to be able to do that? The projector, they had a big fancy projector. We used an old portable projector that we found in the store cupboard. Then we had a webcam rigged up. Of course, they had something a lot more intricate. And then they found a free program online called PoMotion that provides some of the software that helps you program the image that you see on the floor. And it works. What I really want to do is try and encourage you to encourage your students to start playing around with technology and coding in relation to development, in relation to creativity, to get them to try new things. Even if you haven't got a clue about programming or technology yourself. And some people don't. Some people find it a little bit intimidating. But for that reason, we've decided to set up this event. Okay, it's called Day of Code. In the United States, they've already had the Hour of Code, and they got literally millions and millions of high school students across the United States on one day, or 1 week, sorry, spending 1 hour doing something online to do with programming. And ranged from making games to easy programming, other creative activities, cracking codes, which were all done on paper, that you didn't even need a computer. But the whole point of it was to get students more interested in this field, to get them to try it as well, not just in school after they'd done the Hour of Code, but to do it at home. And code.org is the organisation behind that, and they produce lots of resources which are still available on their website. And those are some of the resources that we're going to be using, hopefully, you might even use, or your students might use, on the 19th of June. Well, they'll be able to go on the website. On there will be a whole myriad of resources, links to other websites, things that will help you and your students to have a go at something creative that's linked with technology. That even if you don't teach programming, coding or technology, you might be able to draw on aspects of those for your own subject. Okay, so if you want to have a look, that's the web address. At the moment it's just a single page, but about 3 or 4 weeks before the event we'll be putting all the resources on there, all the links, the videos. We're working with a couple of software companies over here because I think primary school, the younger students, they're the ones who don't have access to the same sort of resources. There's a lot of stuff now for the older students that's quite difficult for some people. But for younger students, we need more resources. So I've asked some of the companies involved to provide more stuff for the younger students. So I hope that perhaps from today's presentation, you might think more about looking at coding, but in particular about the way that you get your students to be creative in the classroom and come up with new ideas for new products and new technology. Okay? And that is it. Thank you very much. What time? I think we're almost done, aren't we? Has anyone got any questions?
Can we try the YouTube?
Yes, shall we see if it's working now? I'll see if, Manuel, let's see if they've got the sound up on here. That's up. what you see on here isn't what I see on here. Come on. You know when you do a presentation about technology and then it doesn't want to work properly? Oh, we might be.
Because a lot of people at school disliked Justin Bieber.
Let's take it back to the beginning.
I've always had a fascination for computers and technology, and I made a few apps for the iPhone, iPod Touch, and iPad. I'd like to share a couple with you today. My first app was a unique fortune teller called Earth Fortune that would display different colors of Earth depending on what your fortune was. And my favorite and most successful app is Bustin' Bieber, which is a Justin Bieber whack-a-mole. I created it because a lot of people at school disliked Justin Bieber a little bit, so I decided to make the app. So I went to work programming it, and I released it just before the holidays in 2010. A lot of people ask me, how did I make these? A lot of times it's because the person who asked the question wants to make an app also. A lot of kids these days like to play games, but now they want to make them. And it's difficult because not many kids know where to go to find out how to make a program. I mean, for soccer, you could go to a soccer team. For violin, you could get lessons for a violin. But what if you want to make an app? And the kids' parents might have done some of these things when they were young, but not many parents have written apps. Where do you go to find out how to make an app? Well, this is how I approached it. This is what I did. First of all, I've been programming in multiple other programming languages to get the basics down, such as Python, C, Java, etc. And then Apple released the iPhone, and with it the iPhone Software Development Kit. And the Software Development Kit is a suite of tools for creating and programming an iPhone app. This opened up a whole new world of possibilities for me. And after playing with the Software Development Kit a little bit, I made a couple apps. I made some test apps. One of them happened to be Earth Fortune, and I was ready to put Earth Fortune on the App Store. And so I persuaded my parents to pay the $99 fee to be able to put my apps on the App Store. They agreed, and now I have apps on the App Store. I've gotten a lot of interest and encouragement from my family, friends, teachers, and even people at the Apple Store, and that's been a huge help to me. I got a lot of inspiration from Steve Jobs. And I started an app club at school, and a teacher at my school is kindly sponsoring my app club. Any student at my school can come and learn how to design an app. This is so I can share my experiences with others. There's these programs called the iPad Pilot Program, and some districts have them. I'm fortunate enough to be part of one. A big challenge is, how should the iPads be used, and what apps should we put on the iPads? So we're getting feedback from teachers at the school to see what kind of apps they'd like. When we design the app and we sell it, it will be free to local districts and other districts that we sell to. All the money from that will go into the local ed foundations. These days, students usually know a little bit more than teachers with the technology. So this is a resource to teachers, and educators should recognize this resource and make good use of it. I'd like to finish up by saying what I'd like to do in the future. First of all, I'd like to create more apps, more games. I'm working with a third-party company to make an app. I'd like to get into Android programming and development. And I'd like to continue my app club and find other ways for students to share knowledge with others. Thank you.
So he's 12. And those skills he learned, he didn't learn in school, he learned outside of school, which is amazing. So if we can sort of harness that enthusiasm and bring it into school, but also let them continue outside of school with this seamless path of creativity, that's what we're aiming for. Okay, thank you.